In this video, we're going to see how we can test for a continuity of a function and see whether or not they're non-removable. Okay, so suppose that I give you the function as x squared minus 3x minus 10. So x plus divided by x plus 2. As you can see, there's a constraint here that x plus 2 cannot be equal to 0. Right? So there seems to be a discontinuity at x is equal to negative 2. Okay, so x cannot be equal to negative 2. However, notice that we can actually remove this continuity if we factor the top, right, the numerator. So we can have it as, so the factors of negative 10 whose sum is negative 3, that's going to be negative 5 and 2, right? So x minus 5 and x plus 2 gives you x squared minus 3x minus 10, and that's divided by x plus 2. Notice that now this troublemaker x plus 2 is cancelled out and we're left with x minus 5. So we can say that this continuity in this case at x is equal to negative 2 is removable. But however, what if you have a non-removable discontinuity, right? So suppose that I give you a function like 1 over x minus 4. The constraint is that x minus 4 cannot be equal to 0, right? So x cannot be equal to 4, right? So can we remove this continuity at x is equal to 4? We can't, right? Because there's nothing in the numerator that will help us cancel this out, right? So this is a non-removable discontinuity because f of 4, the function value at x is equal to 4, is undefined. Okay, you can try to graph it if you want, but and remembering these three conditions, obviously the first one fails because the f of 4 is undefined, right? So the first condition is fails for sure, and obviously we just checked it visually that when the denominator is equal to 0, the function will not be defined. And this is a non-removable discontinuity. So I'm just going to say discontinuity at x is equal to 4 is non-removable. Okay, non-removable. Okay, so let's see what else is there. Maybe we can try one more example. Let's try something like this. The fx is equal to x to the 4th minus 1 divided by x squared minus 1. Let's see what happens with that. So right now there's a constraint. It says that x squared minus 1 cannot be equal to 0, so x squared cannot be equal to positive 1. So x cannot be equal to plus minus 1. Okay, so at these points there seems to be a discontinuity, but we don't know whether or not it is removable. We have to factor the bottom and the top and see what we're going to get. So let's factor the top first. So we're going to get x squared plus 1 times x squared minus 1 divided by x plus 1 and x minus 1. And let's keep factoring because the top can be factored. This x squared minus 1 can be factored, right? So we're going to get x squared plus 1 times x plus 1 and x minus 1 divided by x plus 1 and x minus 1. Notice now the troublemaker here, these two factors they're gone. So you're left with x squared plus 1, which can be defined for any value of x, right? So actually, these two x values, positive 1 and negative 1, they are removable discontinuities, right? So we can say that discontinuity at x is equal to plus minus 1. I should say it in plural, discontinuities, because there are two discontinuities there, right? So I'm just going to say discontinuities are removable. Okay? So hopefully this was helpful. Please subscribe and I'll see you in my next video.